Okay, I think everyone, you should be able to see my screen. And in case if you don't see my screen, please raise your hand, type on chat, or maybe you can share here.
Yeah, we can see now.
Okay, thank you. Okay, so this is the lab topology we see on the screen, right? So I'll be briefing you through the lab topology as well. And before that, let me share about the course content, duration, and other all details, right? So here I'll be using this paint screen. So Cisco SD-WAN, right? Earlier, it was named as Viptela SD-WAN in the past, in the beginning from the inventors, developers who invented SD-WAN. It was a company called as Viptela. Then Cisco overtook this company and they rebranded this flavor of SD-WAN as Cisco SD-WAN. And nowadays, there is a fancy name, Cisco Catalyst SD-WAN.
Sorry to interrupt you. We are in lab screen. Are you showing some other screen as well?
Really? Just a moment. Let me see. Just a moment. Do you see my screen now?
Yes, we can see.
Okay, thanks for raising this. So I shared this paint screen. Initially, in the beginning, this technology was known as Viptela SD-WAN. Then these are the things about 2013, right? When Viptela developed and they were working on this Viptela SD-WAN, and SD-WAN itself, it was not that much known in the market. Then when the boom came in the market, then Cisco overtook this company. They bought this company, Viptela, and they rebranded this technology, right, as Cisco SD-WAN, as Cisco does maybe for the other technologies as well, like wireless, right, and the acceleration optimization. So there are various other technologies where most of the vendors, they do like this, right? Then Cisco SD-WAN, and then they renamed this to Cisco Catalyst SD-WAN. Okay. Then what is SD-WAN? We'll be talking about this thing, right? Why we need SD-WAN? There were certain challenges with the traditional side of the networking. To overcome those challenges, then there came the concept of SD-WAN. So as we all know, it's a booming thing now in the market, and there are multiple vendors who are selling, supporting the SD-WAN technology, right? For all of the vendors like Velo Cloud, right? Then we have Versa, Silver Peak, Palo Alto, Fortinet, right? There are many vendors who are into the SD-WAN service now in the market. So the concept of SD-WAN is same for all the vendors. It's just that their way of implementation of SD-WAN is different. Like if we say a Cisco router running BGP, we also can run BGP on Juniper router, right? The concept is same in the background. We have autonomous system number on BGP on both the vendors. We have prefixes to be advertised. We have finite state machine, FSM, update packets, keep alive timer, hold timers, right? So the concept, the things are same as on concept level, right? But the way they are implemented, each vendor, they have their own proprietary commands and environment. Same is applicable for the SD-WAN. The concept is same of SD-WAN, but the way of implementation, it is different with all the vendors. Okay, so SD-WAN, it comes from SDN, software defined networking. So we do have software in non-SD-WAN environment. In traditional environment, we do have software approach because we have iOS, which is again operating system in software, right? There are certain features that are executed in software and certain features in hardware, right? In traditional environment. So the concept of SD-WAN to use more of the software-based approach to manage WAN side of the network. And when I say WAN side of the network, how our WAN networks look like. So these circles which I have drawn, they are representing routers. Router at, let's say, in one location in London, other one, let's say, in Sydney, third one in, let's say, UAE, fourth one, maybe, let's say, in somewhere in Europe. So for an organization, this is kind of cloud ISP WAN side of the network, WAN links, right? Then for these routers, they have connectivity to ISPs. It can be MPLS, it can be public internet, it can be this point-to-point links, right? So the connectivity for an organization, it looks like this. So for most of the organizations, they would have routers on the WAN side of the network, which would further be having WAN links connected to ISP. So far, I have shared only 6 routers. For some organization, this number can go up to 2000 as well. So just imagine the network engineers in an organization managing 2000 WAN routers, running routing protocols, advertising new subnets, adding new interfaces, new subnets, VLANs, right? Upgrading the routers, managing their configuration remotely, iOS upgrades, backing up their configuration. So there are all lot of tasks, right, to manage the WAN side of the net. So the role of SD-WAN is to efficiently manage this WAN side of things, like remote configuration of the routers, managing the alarms, events, etc. on all the routers. So if we have 2000 devices, it is challenging in the manual environment when we need to make the changes in the configuration manually on all the devices. For, let's say, if there is some vulnerability or some suggestion, some recommendation from Cisco to enable one new command on all 2000 routers. It's a bit challenging into the traditional environment, though we have read scripts there, right? Python, Bash scripting, Ansible, right? There are scripts available to do certain repetitive bulk jobs, right? But for that, people need to be aware about scripts. They need to be aware about that specific scripting, right? So for an organization with 2000 routers, we need at least 4 or 5 people who would be managing the network, running scripts, right? And then for those 4 or 5 people, we need backup plan as well. In case people leave organization, right, they switch their jobs. So anyone who is coming in, they should also be aware about this environment, right? So efficient handovers, efficient managing of the network, then there comes the role of Cisco SD-WAN. From Cisco SD-WAN, what we can do, we can simply push whatever new configuration we want to send on to all the routers. We need not worry about the background scripts, the background things happening at coding level. With Cisco SD-WAN, we have ready GUI interface, graphical user interface, where I just need to give the command line that I want to run on all the routers, on let's say 100 routers, 200 routers. It is up to us. And then I just need to have the list of the routers. We have a ready way to push the configuration remotely onto all the routers. So you can say Cisco SD-WAN, some of the uses of Cisco SD-WAN technology are to automate the configuration of the router. This is one of the advantage, one of the job of Cisco SD-WAN. Anything so far? Any question?
That was good.
Okay, good. So then this is the one of the job of Cisco SD-WAN, right? So now I'll come up with new screen, right? So SD-WAN, software defined things across WAN. Have you heard of the keyword SD-LAN? Software defined local area network. We talked about ISP, right? Then we have routers. These are WAN routers, right? We have a thing called as SD-WAN controller. It is a combination of various components, right? From here, we can manage the configuration routers remotely. So SD-WAN controller is about managing the WAN side of the network, WAN routers and links, right? But behind WAN routers, we have a lot more connections, lot more devices like core switch. Behind core switch, we may have access switches. We may have access points, load balancers, firewalls, right? There can be many devices inside the LAN, right? So the SD-LAN, the logic for SD-LAN is to manage this LAN side of the network, specifically core switches, access switches, wireless LAN controllers, wireless access points. So all those devices are managed via SD-LAN. Whatever optimization advantages, right, we have with SD-WAN, with SD-LAN, we can manage the LAN side of the network. So for SD-WAN side of the technology, the parameter, right, is WAN router only. We cannot do anything on core switch, access switches via SD-WAN controller, via SD-WAN, because it is only about SD-WAN, wide area network. Okay. SD-LAN is about the LAN side of the network. The example for SD-LAN is DNA Center, product from Cisco, digital network architecture. DNA Center, we have a beautiful GUI, graphical user interface, from where we can see what all core switches, access switches, wireless LAN controllers, access points we have in our network. And we can manage their configuration remotely, even for day zero as well. We can configure all the devices at day zero from DNA Center, LAN side of the network. Okay, anything so far?
Is SD-LAN also called SD-Access?
Yes.
Because I heard
Yes,
SD-Access.
yes, correct.
Oh.
So it is also called as SDA, software defined access. Okay. Then the concept of SD-WAN, the key reason for the development, for the kick-in of SD-WAN, right? Okay, let me clean it up. So the key reason of SD-WAN, right? I told you it was, it inherits from SDN. The key concepts are to separate control, data, and management plane. Don't worry if you are not comfortable, if you don't have prior knowledge of the different planes, if you did not get to work on this, right? Don't worry, I'll explain in detail what does these things look like, right? To separate control, data, and management plane. So if we come into the traditional environment, if we have a router, then we have another router, let's say router 2, if we have router 1, then we have point-to-point links or some sort of the connectivity between them, maybe a connection between them, cable, WAN link, etc. Right? Then we run certain routing protocol across this connection, let's say BGP, to manage routing, to exchange prefixes. Then this BGP or exchanging routing, it is part of control plane. Okay, then what is management plane? To log in to the router using SSH, telnet, etc. So this is part of management plane. Then we have data plane. At data plane, routed protocols work like IP to forward data packets or to exchange actual traffic. So in traditional environment, what happens if we are running a BGP on a router, right? What happens if CPU goes high due to this BGP process? You must have experienced this thing. CPU goes high, nearly 90%. Then the data plane and management plane both are impacted. If CPU is high due to some BGP process, the login to the router is prohibited. It is not allowed because of high CPU. You won't get SSH or telnet prompt. Or even if there is a user traffic coming in, if I have some server behind router 2 is connected to router, if I have a user PC behind router 1, if this PC wants to communicate to this server, right, this communication would also be interrupted because of the CPU going high. Now, because of the control plane, management plane, and data plane, these all three are impacted. The key reason for SDN invention, use of SD-WAN, is to separate these three different planes. Now, routing exchange would altogether be across a different path, management, again, different path, and data plane on a different path. So we will have three different paths for management plane, control plane, and data plane. This is the key use of SDN, software defined networking. And this concept of separating control, data, and management plane across WAN side of the network, then this is called as SD-WAN, software defined wide area networking. Anything so far? Any question?
So good so far.
Okay.
Yeah, Pradeep, I just have a single question.
Mhm.
So, although the control plane and data planes are separate in the SD-WAN, okay, all the
Yes,
routing season, all the routing exchange, routing tables are on the control plane. So
absolutely.
what happened in case of the CPU utilization on the data plane on the VH side? If that get failed, what about the the current data forwarding? Because even the VH keeps a copy of the routing table.
Right.
So what happened to that?
So you mean if the CPU or something wrong at data plane level, right?
Yes.
So of course, if we are talking about data plane, we are talking about the actual traffic. If there is something there, then of course, even though control plane is working, but it's of no use to us, right? Because data plane is impacted. Because ultimately, what is the goal of setting up routing protocol routers is to let this PC talk to this server. This is the ultimate goal of networking, right? So if data plane is interrupted due to hardware or some reason, then even if control and management plane is there, it is of no use to us, right? Does that answers your question?
Yeah.
Okay, good. Then it was about the concept of SD-WAN. So all the vendors, right, whosoever are in the market providing SD-WAN services, technology, for all of them, the concept is same, to separate three different planes. One, another key use of SD-WAN to separate control data and management plane, right? So if we say SD-WAN advantages, separate control data and management plane. Then automating WAN network management, or you can say WAN routers management. We talked about the example for this, remote configuration, bulk configuration remotely, remote iOS upgrades. We can push the iOS images to the routers remotely, be it 1,000 routers, 2,000 routers. With one click by selecting the devices, we can push the iOS files. So it would be parallel push to multiple devices. Also, we can give one combined command to upload the iOS file onto the X router and activate as well to upgrade the device as well. We can do this as a clubbed job coupled to push the iOS and activate simultaneously. Or we can do these jobs separately. Only push the iOS for now, and we will be activating the new iOS, rebooting the device later when we may have maintenance window or something like that, right? So we can manage remote OS upgrades from SD-WAN controller. We can back up the configurations remotely. We can see the alarms, events happening across whole network, top talkers, top applications being utilized, right? Then number of devices which are up or down in our network. Let's say in our network, if we have 2,000 devices, out of 2,000 devices, there may be a situation that under 10 devices are up and 90 devices are down, right? These all things will have ready in a ready dashboard, which is the home page of SD-WAN controller. In this home page, we will see how many devices are up, how many are down. Then alarms, major critical alarms. Then we'll have a list of the devices, top talkers, top applications being utilized, top devices with, let's say, highest CPU, memory, etc. Okay. So the advantages of SD-WAN to separate. This is the key concept of SD-WAN for the invention of SD-WAN, right? Then automating the WAN routers management. As I told you before, this thing can be done via scripting, Python, Ansible, etc. But with SD-WAN, we have ready things that we can, with Python, if we use Python scripting to do the bulk configuration of the routers, we need to write the script, right? You can say with SD-WAN, we have inbuilt script where we will have graphical interface to simply input the configuration that we want to send to remote routers. We don't need to look into the actual coding with whatever is happening in the background. Then third, we have security. With traditional networking, do we have security there or no? Is our network secure in traditional networking or no?
We could secure it via IPsec tunnels or GRE tunnels.
Absolutely. So if we have, let's say, this is some ISP, let's say level 3. From level 3, we are subscribing internet line, say internet 2, and we have internet 1. If we simply connect these two routers, if we ping to each other over internet, we can ping. There would be IP reachability through internet. But this path is not secure. Why? Because anybody, whosoever is sitting here, there on the routers, they can sniff into our packets. To secure the communication over internet, we can build up virtual tunnels or IPsec tunnels. Now, we do have this thing of security in IPsec, but it is not scalable or not an efficient thing. Why? If there are 2 routers, we are good for IPsec tunnel, IPsec security. But what if we have 1,000 routers and we want IPsec tunnel secure path across all 1,000 routers? It is not efficient, right? So with SD-WAN, we have IPsec security inbuilt onto all routers. Be it we are using MPLS links, be it we are using internet lines, SD-WAN security would be there by default, and these IPsec tunnels would be established between all the routers by default. We need not do anything into the IPsec configuration. It is automated. If IPsec tunnel is not established between 2 routers, then the LANs across these 2 routers, they cannot communicate to each other. Their communication would be blocked until this IPsec tunnel turns up. So we have native security or inbuilt security into SD-WAN. This, we talked about IPsec security, right? Along with IPsec, we have TLS, a new name for SSL, certificate-based security. So SSL, we use certificates for SSL. So certificates are nothing but they contain digital signatures. Or in simple words, you can say in certificates, what do we have? Secret codes. So with SD-WAN, these two are there by default. IPsec and SSL or TLS based security. So that is why we say SD-WAN network is secure. In traditional networking, IPsec is optional, right? In SD-WAN, if we use, let's say, private lines, MPLS lines, or if we use internet lines, security is there by default. Okay. Then we can use diverse transports. We cannot really efficiently utilize in traditional side of the networking different type of WAN links. We cannot really club them. What I mean here, if I have a router, let's say 2 routers with different type of WAN links. If this is my MPLS link, I have second link as internet line, third link as, let's say, 4G wireless link, right? Then I'll have cable going via port to, let's say, different ISPs, different routers, different connections. So if I have a PC here, server here, connected behind the routers, when there is traffic coming in from this PC to land onto this router, right, router 1, router 2. If I want this PC to communicate to this server on right hand side, it is really inefficient, right? We cannot really load share across different type of WAN links in traditional side of the networking. If they are similar type of links, if second link is also MPLS, then it is okay to load share here. And even that load sharing is not efficient into the traditional side of the networking. But with SD-WAN, this thing is there inbuilt. This is the default behavior with SD-WAN, that we can utilize different type of links between two routers, so that now this PC can either go via this path or via this path, or let's say third path. So this communication between PC to server would be load shared across three links. This is the default behavior of load sharing, right? We can even prioritize. We can say that the primary path for communication between PC to server should be via MPLS cloud or via internet or 4G. We can define these priority for any number of applications and any number of users. Source-based, destination-based, right? This thing in traditional environment, this thing is called as PBR, policy-based routing. So it's a bit complex to configure and manage policy-based routing in traditional networking, but with SD-WAN, it is natively inbuilt. We simply select source and destination and we specify the exit interface. That's it. Anything? Any questions so far?
So for example, actually it's one basic question only. I have two MPLS connection in my office. If I want to migrate to SD-WAN, so I need to replace this MPLS completely, or how that migration?
Okay, good one. So now if may I erase this thing? Okay. Now, what happens in legacy environment? In existing environment, we have various routers and they are connected to various cloud, various links, right? So now, if I say this is one of my router in London, another router in somewhere in US, right? Then they would be connected to, let's say, some MPLS ISP, MPLS cloud. Now, this is how the connection look like in traditional environment when we don't have SD-WAN. This would be user's PC in London, and this would be, let's say, user PC or some server, SAP, ERP application, Citrix, etc. It could be connected like this in traditional environment, right? Then when the SD-WAN comes in, what happens? We can still utilize these WAN links. It is just that when we transform our router in London to SD-WAN environment, to SD-WAN side of configuration, so whatever configuration we have in legacy side on the router, we need to change these configuration to the SD-WAN side of the configurations, which would be totally a different environment, you can say. Kind of replacing Cisco router with Juniper router. You can think of that much transformation, right? Different set of configuration that we do. Similarly, we need to do that for the other side as well, or for all the routers. One router in traditional networking, one in SD-WAN networking, right? There cannot be direct communication between them. I'll explain when I say direct communication, right? For now, to transform one router to SD-WAN environment, we need to totally change their configuration things, right? Then there would be, let's say, if I transform my US router into the SD-WAN domain, then there would be IPsec tunnel established between two routers. And whatever communication which was happening before this user PC and this user PC across this black solid line, right? Now their traffic, their packets would be exchanged via this yellow path, overlay path, or you can say overlay or virtual tunnel, which is IPsec based. So SD-WAN is the technology of overlay. Here, all packets, all communication would be over the overlay path. One is overlay, other thing is underlay, these black solid lines, right? So overlay path, all communications between devices in SD-WAN domain, it would be across overlay path, nothing across underlay path. This black solid line, it cannot be used for communication between this user PC to this user PC, from left hand side to right hand side. Whenever users host machines which are connected across different sites, if they want to communicate across SD-WAN domain, their communication would always be via yellow overlay virtual IPsec tunnels. That is why it is said everywhere that if we have SD-WAN, it is not that MPLS would be phased out. MPLS would still be in use as underlay path. Clear, everyone?
So MPLS will be there, but by using the SD-WAN router, we are creating time.
Absolutely.
Okay. But still, we need to pay for that vendor, that MPLS.
Absolutely. Yes.
Okay. So, but it's additional cost only, right? What and centralized, okay, but
Now, the thing that you talked about, right? Ghost. So just think of the existing environment where we have internet line as well. On same routers, they are connected to internet lines as well. Can you efficiently configure and manage these lines, primary, secondary? Because between two routers, if we have internet lines, you would be configuring IPsec tunnel over internet lines, right? Now, think of 2000 routers. How many IPsec tunnels you need? Lot many, right? Even if we configure hub and spoke topology or DMVPN, then also there is extra overhead, right? To efficiently steer the traffic across MPLS link or internet link. But with SD-WAN, if we have MPLS based link, if we have internet based link, then we can simply write policy, some condition in GUI that match voice traffic, send it across MPLS based IPsec tunnel, match FTP traffic, send it across internet based IPsec tunnel. We can define these using policy or conditions, which is very much easy into the SD-WAN domain. It is very complex in traditional side of the networking to send different type of traffic via different IPsec tunnels. Are we good?
Is SD-WAN is going to replace the MPLS, correct?
No. I told you, MPLS can still be used as underlay link, as underlay technology.
But somewhere I have gone through, I remember, like, see, once we have SD-WAN in place, so we can only we can have internet link.
Okay. So it is, you just think of in our day-to-day life, if we have flyovers built up on the top of roads, right? Can a flyover be built up? Can a flyover stand at its place without a road underneath? No, right? Similar is the concept of SD-WAN. When you talk about flyovers, that is kind of SD-WAN. When you have base of that flyover, that is on the road, right? On surface. So that surface is MPLS. Earlier, what was happening? All the traffic was passing through straight road. Flyover was not there. Now SD-WAN is kind of a flyover. Now all the traffic would be crossing flyovers rather than passing through the straight road, right? That straight road in SD-WAN domain, it can be MPLS, it can be internet, but always the flyover would be the overlay path. Always packets would travel onto the overlay path. Be it that flyover is built up on the top of MPLS road or internet road. Good.
Can
So
you please
if
can
I
you
want
please
to study
explain
SD-WAN,
on overlay and underlay?
Sure. So if I draw maybe separation to explain this thing for traditional environment, and here we have SD-WAN. In traditional, when I say known SD-WAN, okay, then we may have two routers. They are connected via MPLS link and via public internet link. There would be WAN links. So if I have user PCs, right, and there are, if this is PC1, PC2, right, then I have, let's say, SAP server, or let's say CUCM, some voice server here, and if I have, let's say, FTP, file sharing or file backup, etc. Then this PC would be connected to router somehow via core switch, access switches, similar here, right? In traditional environment now, when PC1 wants to communicate to CUCM, right, the packets would be landing onto the router. Now we need some sort of configuration on this router to say that which direction voice traffic should follow and on via which link the traffic for the file sharing should follow, right? Now, voice traffic, let's say I want to say that it should follow via MPLS link, right? Then if PC1 is sharing file as well, it should follow this link. This decision on the router, it is very much complex because so far we are talking about 2 applications. There can be 100 applications, right? It is really difficult to manage this distribution of traffic across different links. And why we really want to do this, to send voice traffic via MPLS link and FTP traffic via internet links, because MPLS link, it always has guaranteed or better performance. It would always have better latency, no packet drop, no jitter or very less jitter, right? Whereas via internet links, it is always expected, it is always probable that it may have degraded performance. Then what is the probability for MPLS links, right? Now, if we talk about overlay and underlay now, these black solid lines, they are underlay path, direct path, right? This is what we use in traditional environment. Now, if we say about the communication between PC1 to FTP server, via internet, this path is insecure. Anybody can sniff our packets. So what we do, we configure a tunnel across this path between router 1 and router 2. This is virtual. This virtual IPsec tunnel is called as overlay tunnel or overlay path tunnel. Be it virtual, be it IPsec or be it GRE. If you have heard about GRE, that is also overlay. Overlay on the top of underlay path, on the top of these black solid lines. For this black solid line, there would be one physical interface here. Let's say gigabit 0/0. Here also there would be some port on ISP side, gigabit 0/1. Similarly for router 2. But for this blue overlay tunnel, there won't be any physical interface. It would be virtual interface of IPsec tunnel, like loopback, like interface tunnel 1. This is the name of this IPsec tunnel. Just like we have name gigabit 0/0, the name of overlay path, name of the overlay interface is interface tunnel 1. It is known physical interface, virtual interface. Okay. Why we configure this overlay path? that the packets are encapsulated. So when we say overlay, that means we have some package to deliver. It may contains XYZ things, right? So whenever we courier, whenever we deliver this package to other location, right? Anybody can simply see what is inside the box, right? If we haven't packed, if we haven't done taping on that box, right? So what if we pack that box into another box and tape it and properly make it a closed box, right? Nobody can see now our packets, right? Our actual package, what is inside. Same is the applicable for this overlay path. At underlay path, anybody can look into the packets, but when we configure tunnel, then nobody can see what are our packets, right? Does that answer now?
Yeah, so can we
Logically,
create
the
overlay path
R1.
over MPLS?
Yes. This overlay path can be configured across MPLS path as well, but it is usually not configured in traditional environment because MPLS links altogether, they are already safe, secure because they are across private provider
So
path
can we say mostly it overlays over internet?
in traditional side of the networking. But in SD-WAN side of the networking, it is mandatory, even if we use MPLS links. This is the advantage with SD-WAN, that if we have, let's say, similar links, right? This IPsec tunnel would be there as mandatory thing on all the links. It is not optional. In traditional side, it is optional.
Okay, I have doubt here. See, still the point which you mentioned, like even the SD-WAN is still the existing MPLS still, but in SD-WAN the tunnel will IPsec tunnel will get automatically formed, correct?
Yes.
But how if we have MPLS? Because what I read is something like so once we have the SD-WAN in place, it will be replacing the MPLS. So we can have only the internet link and the 4G. That is what I.
So I will say it is not actual thing 100% correct that SD-WAN would replace internet. But let me tell you why some people, why at some places you see SD-WAN would be replacing MPLS. Let me tell you why.
Yeah, that is
First
what
thing,
the document somewhere I saw actually.
and you need to understand now, it is not mandatory to replace. It is optional if you want to replace, right? And why we really needed MPLS at its place in traditional site. Why MPLS was preferred over internet path? Do you know the reason? Because of
For
the
guarantee.
Because this cost
yes,
more cost and internet link is cost.
Guarantee.
yes, the
Main is cost
performance
effective.
guarantee. Yeah. So MPLS is expensive.
Yeah.
And internet is cheaper.
Yes, yes.
But still, we preferred MPLS in the traditional networking. Right? It is other way. MPLS is expensive and still it was preferred. It is still preferred in traditional environment. Why? Because of the performance guarantee. Via MPLS link, it would be mostly 95% of the places, it would be one provider, be it L3, level 3, right? This connection of MPLS links, it is via one provider, right? But internet, what is it? It is a collection of ISPs. So if I create another picture here to help you understand, how does MPLS connection or MPLS path looks like? If this is MPLS from level 3, right? There would be one router of level 3 here, one here. One in, let's say, UK, other in US. Level 3 would be having their backbone setup to let different locations connect to each other. So their network is managed by level 3 only, one common company, right? They would be connected to UK router, the router, or let's say our site in London. We have one site in New York. It would be connected to a router of US, right? This is MPLS path. Now, what is internet? At London, I may be connected to some ISP, let's say Colt. I may have internet line from Colt in London. At US, I may have internet line from AT&T. They are not same provider in case of internet, right? And even they may not have direct connectivity between Colt and AT&T. They may have their uplinks, their connectivity like this. Now, Colt and AT&T, they themselves are not directly connected. They are connected via different ISPs. This is what internet is. Okay. MPLS cloud, MPLS ISP is one entity only. But internet is collection of different ISPs. So now the performance guarantee, the latency guarantee, right? What, let's say this level 3 provider guarantees that I can give you the latency of, let's say, 80 milliseconds between London to New York. 80 milliseconds and let's say 0.1% packet loss and 2 milliseconds of jitter. Right? Nobody will give you this much level of guarantee via internet path. Why? Because Colt only has authorization across this path. Colt does not guarantee this link or this link, right? Now, then there comes the responsibility of AT&T. AT&T is responsible here only. That is why it is said that MPLS it has better performance. Performance is guaranteed because MPLS is managed by one single entity, but internet is collection of different ISPs. And even when we say collection of different ISPs, this path is not secure by default. That is why we configure overlay or IPsec tunnel on the top of internet lines like this. So nobody can see our actual traffic when we are configuring this yellow IPsec tunnel. Is this clear now?
Yes.
Anyone?
Yeah,
yes.
Question. So what I heard about is SD-WAN is a cost-effective solution.
Sorry, could you please speak louder?
Yeah, actually, I heard about SD-WAN is cost-effective solution.
Yes.
But we are maintaining the same MPLS on internet. This is our
okay. Okay.
But we are adding more cost. So if I migrating,
I'll tell you the next advantage that we have with SD-WAN. I was coming on to the cost, reduce cost, and I'll tell you now how.
CapEx.
Yes. Right.
Yeah.
There are various things where we save cost. How? First, why we now, can someone tell me why we switch to MPLS links? Why we keep using MPLS links in traditional environment? Because of the performance guarantee. Right? And security. The banking financial institutions, they are reluctant to move on to the SD-WAN. Or in traditional environment, the financial institutions, they don't want to switch to internet lines because of the security reason. Because even if we configure IPsec tunnel, still there are chances that your data is at risk, right? Now, using MPLS, we had additional security because it was managed by one single entity. If you have your data theft, data loss, etc., you can still ask someone, right? But when there is internet, Colt does not guarantee the data security. If there is data theft, data loss, something like that, no provider gives a written responsibility that I would be responsible in case something happens. Why? Because internet is collection of multiple ISPs. They don't have authorization over this one. Colt does not have any authorization over this path, right? So now, if we come over to the cost, right, we used MPLS links because of the performance guarantee and security. That this path is secure by default. Now, with SD-WAN, we are using inbuilt IPsec and SSL security. IPsec and SSL based security. So what we can use, one of the key reasons of moving to MPLS was security and performance, right? Now security is overcome here. Why? Because we have IPsec and SSL natively inbuilt. So that security aspect is here now clear. That we don't have any risk now.
So even MPLS also it will be natively inbuilt, is it? Even MPLS
So
link.
no. So for SD-WAN domain, yes. Even for the MPLS side of the links, IPsec and SSL security would be there by default. You can say double security, 2 layers of security, right?
So you mean
Why?
it's IPsec over MPLS, is it?
Yes, correct.
So by default it will be formed how it is IPsec over
Absolutely. Yes,
Okay, so in that case, it is not going to replace the MPLS. MPLS can
absolutely.
exist in the,
Yes.
even in the SD-WAN.
MPLS is going to stay there. The reason why, the next point I was coming on to, the reason why we stick to MPLS was security and performance, right? Security, now it is available with this IPsec and SSL, but performance is the key reason still here. Internet, it still does not have that much performance that we need for our networks to work. So still MPLS are going to stay. Why? To steer the critical traffic. So this happens in the almost all organizations, whoever are using SD-WAN, that critical traffic is steered via MPLS links and non-critical traffic via internet baselines. When I say critical,
And
like
what
voice.
is that? One more like the Ethernet point-to-point link actually. Is there any difference the internet link, MPLS, and point-to-point Ethernet link?
So point-to-point Ethernet link, you can still consider it equivalent to MPLS links.
Okay, but it will not use the label things and all.
So even if you talk about MPLS link, you don't have labels here on the access side of the link, right? Labels come into the ISP backbone.
Correct.
Right? So even if you talk about point-to-point links, still it is an access link only. Right?
Because
so,
in my environment, SD-WAN we have, but we don't have MPLS. We have internet link, and in some remote places we have 4G.
Okay. So now, let's talk about the point-to-point links. We talked about MPLS link. We talked about internet links, right? Point-to-point link is like a direct cable between 2 routers. Right? But again, this point-to-point link, it is a point-to-point or it is a local as long as you are connecting 2 routers which are co-placed. But if you have a router in, let's say in US, other one in UK, again, you cannot have this fiber deployed for yourself, right? Again, you are going to some provider to ask for this point-to-point link, right? This provider can be again Holt, who is providing layer 1 link, let's say, only dark fiber, only a media for your 2 locations in US and UK to connect. Again, you are using some provider, and again, they would be using, let's say, MPLS in their backbone. For us, it would be a layer 1 path. And if we talk about this link, it would be a layer 3 MPLS path for us, and it would be a kind of layer 1 MPLS path for us.
So even in the point-to-point link, the IPsec, how it will be formed actually?
So with layer 3 links, we have IP address here and here. But with layer 1 link, we'll have IP address here and here. Okay. So end-to-end IP addresses we will have, but with layer 3 MPLS link, we are not having end-to-end IP addresses. Instead, we have IP address on different segments. Okay. Okay. Then we were talking about coast, right? Now we were on the here, right? So could you mute yourself, please, in case you're not speaking? Thanks. So now, if we have 2 routers here, right? Then this router is part of control, management, and data plane. 3 different planes we talked about, right? Then, if I have another router, let's say 2000 locations, right? Then this R1 needs to know the prefixes of all 2000 locations, right? Even if R1 does not need, right? So if I come here, if we have different locations, they have connectivity via, let's say, point-to-point link, MPLS link, whatever, right? If they are using BGP as routing protocol, router 1, 2, 3, 4. These 4 routers, they would be receiving the routing prefixes of all 4 locations, right? What if site 2 is my data center and this is my branch site, 4 is another branch site, right? So first is also one of my branch site, router 1. Now, what if I only need communication between these 2 locations, right? Do I need the routes of these sites? No. But still, BGP would be communicating my LAN prefixes to site 3 and site 4, and similarly other way. Router 1 would be receiving the prefixes of router 3 and 4, which is not needed. So the CPU is being wasted here, CPU capacity. I need a router for branch 1, which is, let's say, connected to 2000 sites, a network of 2000 sites, right? To handle that network, to be connected in a network of 2000 sites, I need a router at branch 1, which has capacity of, let's say, for example, which needs a RAM of 1G to handle 2000 devices routing, to send BGP packets, to receive BGP packets, keep alive, update timer, advertisement interval, finite state machines, all those things, right? Now, with SD-WAN environment, what happens? If we have different locations, right? We have SD-WAN controller. All the routers, they would simply be exchanging their LAN information, their prefixes to SD-WAN controller only. So the end routers, they are now offloaded for the control plane thing. They need not exchange prefixes directly between them. Earlier, the prefix exchange was directly with other sites. Right? Now, this communication of exchanging prefixes between different sites is reduced, offloaded. Why? Because routers now need to send their prefixes to SD-WAN controller only. Now, this is the job of SD-WAN controller to broadcast, reflect these prefixes to other sites, depending upon the route maps or whatever we configure on controller. Whichever route maps we configure in the traditional networking to manage AS path prepend, local preference, traffic engineering, whatever we do, right? Community setup, matching community, doing some route manipulation, everything is now at SD-WAN controller. Router simply what it does, it simply sends its prefix to SD-WAN controller. That also using lightweight protocol, which is called as OMP, overlay management protocol. It is similar to BGP. So overlay management protocol is the protocol used to send prefix to SD-WAN controller and via SD-WAN controller to other sites. Now, these routers need not exchange routing information directly. Think of the environment where we have, let's say, 3 routers. They are having point-to-point links, as somebody just talked about. If we are using point-to-point links, then these 3 routers, if they are running BGP or OSPF here, right, they would need to exchange, they would need to synchronize their OSPF database across 3 routers, right? Think of, let's say, 100 routers. where we are running BGP or let's say OSPF, we need to exchange their information between all the routers. It is causing overhead for these routers to maintain OSPF database. Now, even in the traditional environment, just think of if we are using OSPF for 3 routers. What if we have 4th new router? Then I would have OSPF adjacency, pairing, etc. with all 3 routers, right? Now, forget about OSPF. That we are not using OSPF. Now we are switching to SD-WAN domain. What we will use, we will create one SD-WAN controller. So all 4 routers, now they would communicate with SD-WAN controller for the purpose of exchanging routes. They won't be exchanging OSPF, BGP, etc. directly, right? And let's say we are connecting 3 new routers into network. They would simply be connecting to SD-WAN controller to receive the prefix information of existing 4 routers, as well as to advertise its LAN subnet prefix to all the routers in the network. So it is the job of SD-WAN controller to receive the prefix information and to advertise the prefix information. Are we good?
Similar to route reflector.
Absolutely. SD-WAN controller is route reflector.
Okay. So you mean to say all the traffic, even the edge device, should go through the control
plane.
We can also have direct
no.
site.
So we have SD-WAN controller. In SD-WAN controller, we have 3 different virtual machines, 3 different components. For one of the component, it is called as vSmart, and its job is to manage control plane. Another component is vManage. The job is to manage management plane. Now, if we have 2 routers, they may be connected via, let's say, I assume one link only. Okay, this is their physical link. Now, if this router 1, it has some LAN information, it's in its LAN, let's say 10.10/24. Router 2 has subnet 20/24. This 10.10.10 would be advertised via router 1 to vSmart. What vSmart will do, it will broadcast this to other all sites, be it 5,000 sites, be it 1 site. This is the job of vSmart. This router is not concerned about propagating this prefix to other all sites. Okay, then this is the job of control plane. Just managing the routing.
Yeah, that's you are talking about the route propagation, route advertisement. But
absolutely.
Data traffic can be.
Yes, I'm coming on to data traffic now. This is the control plane, right? And we have this route exchange to vSmart to control plane. It is not a plain path. It is SSL secured path on the top of which route exchange will happen. This is we have additional security. This SSL certificate based virtual tunnel would be established first, and then prefix would be exchanged on the top of this tunnel. We altogether now have secure path, right? Then we have another SSL tunnel for management plane to push the configuration to router 1, to manage iOS upgrade, to capture alarms, backup configuration, everything. This happens on the top of this SSL tunnel. So separate path for management and control plane. Right? Then we have third tunnel between router 1 and router 2, data plane. The actual packets would travel on the top of this tunnel between router 1 and 2 directly. So router 1, it will have 3 tunnels. One data plane tunnel to router 2, one SSL tunnel to vSmart for control plane exchange only. Now, all these tunnels, they have their dedicated jobs. They are not doing shared job anymore, which was the case of traditional router, where it was having unified control, data, and management plane. Control plane, data plane, and management plane. It is unified on a router, but in SD-WAN domain, all these three planes are segregated. Control plane towards vSmart, management plane towards vManage to push remote configuration only. The job of this management plane is only to do the management plane jobs. The control plane thing, the job is only to manage control plane information, routing exchange. The job of data plane is to send the actual packet. If now I have a PC sitting here who wants to communicate to a PC on right hand side, their communication would be via this data plane tunnel. There is no job, no role of vSmart or vManage in actual data communication. Now, if what happens if, let's say, this component is unavailable, let's say it goes down, then data plane would keep working. These PCs can still communicate to each other for some graceful period of time, let's say 8 hours. For 8 hours, these PCs, these routers, they don't have any dependency on control plane and management plane. Just try to relate it to the scenario where I shared. If CPU goes high due to BGP, our actual data plane and management plane, they are also impacted. Here, all planes are independent.
That is something like the phase 2 lifetime, correct?
Yes, correct.
I have a question.
Yes.
In the data plane, is it IPsec tunnel that form between the edge router 1 and 2?
Yes.
IPsec, right?
So data plane would always be a IPsec tunnel.
Yeah, thank you.
And just kindly, this is a vSmart and vManage is the Cisco devices. So is the same working for Concerto in director for Versa same?
Yes.
Okay.
That is why I said in the beginning, right? The concept is same. Cisco, Juniper, HP, Huawei, Nokia, all are doing routing. All are running BGP. It is just that they have their own way of implementation. So vSmart is managing routing information. So name is vSmart with Cisco SD-WAN. With, let's say, Versa, it could be director or maybe name could be different, but concept is same.
Yeah, the GUI path is the same concept, na? Ki any changes
Yes.
for IP and then
Absolutely.
subnetting and then
Yes.
pool and then path of device.
Yes.
So from the VH to vSmart, is it encrypted traffic?
Yes. SSL tunnel, certificate based tunnel. So there are several layers of security. Do you know why VIPs are given different layers of security?
So what is the difference between IPsec tunnel and SSL tunnel?
I'll tell that as well, right? So now SSL tunnel is basically we are using certificates. So certificates are used to encrypt or decrypt the traffic, right? IPsec tunnel, we have certificate as optional thing. So just think of that. Now you are logged into this Zoom session, right? You have certain password being provided, let's say, right? Then that would be kind of secure IPsec tunnel. Like we have fixed password that, let's say, admin team given you some password 12345 to join this meeting, right? And when you log into Zoom session, you input 12345, right? Now, what if admin team gave you, right, certain random number 45678, right? Now, ultimately, when you input this value in the background, ultimately the value which would be input to join this meeting would be 12345 only. But it is just that you won't be given exact key. You would be given some different key which would transform to 12345 using inbuilt algorithms. On high level, you can say difference between IPsec and SSL is like this. So SSL is bit more secure than IPsec tunnel. So it is, you can say SSL is advanced version of IPsec.
It's something I can think of like remote VPN. Is it similar to
Yes.
SSL?
Yes. So again, remote VPN is another way of connection where you need security, right?
Yeah, it is
So
SSL actually, remote VPN.
yes, yes.
So normally IPsec is a site like router to router, but
Yes.
for VPN like client, we'll have agent in any
Yes.
like different
And this IPsec tunnel, data plane tunnel, would only be established once SSL connections are up towards control plane and management plane. If this, you can say basically data plane is dependent upon these tunnels, these SSL connections. If these SSL connections are success, then only this site to site or router 1 to router 2 IPsec tunnel would be established. Or you can say these SSL connections, they work as phase 1 for this data plane IPsec tunnel.
This SSL is UDP or TCP?
So we have optional, right? We have both options. If you want to use it as UDP or TCP, we have option to click that. If you select this to be TCP, then it would be TCP mode. If you select that to be UDP, then it would be UDP mode. We have both options.
If data plane is impacted, then nothing will work, right?
Yes, that's correct. But it is rare, right, that only data plane is impacted. The reason why I say, because all these three tunnels, right, data plane, management and control plane tunnel, right, they are connected on the top of one physical link. This one. If you have three flyovers built up on one single road, right, is there probability that one of the flyover going down, another two? No. They all have dependency on same underlay path, right? So it would be rare situation that only data plane tunnel going down and the vSmart and vManagement, their SSL connections not going down.
As the controller is done.
Sorry, one more time.
Unless controller is done.
Absolutely. For if controller would be down, then it would be kind of a control connection down for other all sites as well.
Yes.
But again, data plane, I told you, for some period of time, it does not have any dependency on these SSL connections. Once SSL, so the sequence would be like the SSL to vSmart should be up first as first step, right? As second step, I would say. First step, I'll explain what is that, right? Then SSL to vManage should be up as third step. Then only IPsec tunnel between router 1 to router 2 would turn up as fourth step. First, the SSL connection between router 1 to vSmart should be up as second step, then to vManage, third step, then the IPsec tunnel between router 1 and router 2. It would turn up as fourth step. Now, subsequently, in case these go down, then also this would keep working. First, IPsec tunnel has dependency to turn up, but once they are down, right, the SSL connections, then there is no dependency for 8 hours, let's say, right? Are we good?
We say orchestrator come first before all of this?
Sorry, can you repeat, please?
Orchestrator, vBond.
Yes. So this is why I said second step or third step. At first step, we have vBond. So this is, I have drawn third box, which is
I just
vBond.
have doubt actually. I should be first step V1, second step vManage, then third is vSmart, no?
So you can say first step is vBond. This is for sure, right? For
Yeah.
vSmart and vManage, they are kind of parallel. You cannot really find out would it be vSmart first or vManage first because they are parallel.
Because the vBond will share the IP of the edge to both
Yes.
vSmart
Yes.
and vManage parallelly, correct?
Correct. So you can say
So it is vBond also SSL, the tunnel forming
yes.
SSL, and
So I did not touch about the this tunnel, there would be one tunnel to vBond, which is kind of first step, right? It would always be UDP based SSL tunnel, and it is a temporary one. We will talk about this in more details tomorrow, right? The
So
use of this.
TCP is the permanent one, huh?
Yes.
Okay,
So,
UDP is temporary. Okay.
So UDP based SSL tunnel is named as
But
DTLS.
I'm looking at vManage Configs.
Mm-hmm.
Can we say vManage Configs because control before the control plane is established, management must have been.
No, they are both parallel, you can say.
Okay.
So
you talk about DTLS, na?
Yes.
Tell about DTLS. What is?
Yeah. So TCP based SSL is called as TLS, and UDP based SSL connection is called as DTLS.
What is the full form?
Distributed. This is TLS is transport layer security. New name for SSL.
UDP based.
Okay.
Transport layer security.
UDP is distributed transport layer security.
Yes, absolutely. Just a name, just a fancy name, you can say. TLS is transport layer security.
So what is the version it will use actually? We have TSL some version 1, version 2, no?
Version 2.
Okay, and as you mentioned, like this SSL all full based on certificate actually.
Yes.
So in the environment, do we have CA server?
Yes,
like
we need to set up that as well. So we have both options. If you want to set up, you want to use your own certificate authority, or if you want to use the commercial certificate authorities, Cisco also act as certificate authority. So all options are open.
Like we are setting up in on-prem in our own vBond vManage, then we have to have the CA certificate authority.
That's what we will do in our lab.
Okay. In the cloud, the vendor will take care, is it?
Yes.
So the CA is it external CA or internal?
It is optional. For us in our lab, it would be internal CA. We will be setting up certificate authority on a Linux machine.
Okay, while configuring vManage vSmart, we will point to that CA server, is it?
Yes, correct.
Okay, then it automatically comes. Okay. And one more doubt I have is, see, initially when I started, like almost 3-4 years before, that time it was Viptila, correct? VH.
Yes.
So and then Catalyst now I think 8300 200 series came actually.
Yes.
So they have the iOS XE image where the SD-WAN also. So why they replaced actually? Why Viptila nowadays even my environment also Viptila they removed actually most of the places. So I'm not why they
see the key reason is the commercialization, right? Business. Viptila, company who developed SD-WAN, right? They had their hardware named as VH, which is like let's say Cisco 4000 routers. VH, if somebody is not aware of, right? VH is a hardware line just like Cisco routers, right? They have different models, VH100 based on their capacity, 100,000, right? They were called as VHs, physical hardware. There can be software version of VHs, so there can be physical or virtual VHs. Then there comes Cisco routers, right? Cisco routers, we do have again physical and virtual environment, right? For Cisco routers, Cisco SD-WAN only works on the Cisco routers having iOS XE images.
why it's specifically 8300 series actually?
No, not only 8000. So Cisco 1000.
ASR also support?
Yes, ASR 1000. And now Catalyst series, we have Catalyst 8300 or 8000, right? Devices. So on all these devices, Cisco SD-WAN can only run. If you go find out Cisco 800 router.
ISR also support?
When you say ISR, right? So these 1000 and 4000, they are ISR only.
Oh, okay.
Yeah. So
Pradeep,
Cisco, yes.
yeah. So before you wrap out, okay, just want to know, something about. So I've understood the topology on the, site level. So
Mm,
on the controller side, where our controller are located, okay, how's the
mm.
topology at that side? How we as, come to know how to reach to that, vSmart or we manage, I mean, how that, gets the routing, or how vSmart, further propagates those routes to other V edges. So what exactly is the network topology at that side where our controllers are located? How does that work?
So yes, we will talk about that tomorrow, right? In more details than what you
Mhm.
asked, right? So we will see everything, how these devices are connected, how they get to know about each other, everything we will see tomorrow.
Okay.
Okay. Yeah, yeah. Thanks for raising this. So Cisco 800 routers, Cisco ASR, let's say 9000 CSR series, they don't support SD-WAN. Okay. Again, these for them physical, virtual, they all support Cisco SD-WAN. Now, the reason initially when Viptela was overtook by Cisco, no, none of the Cisco routers they supported SD-WAN. So Cisco was lacking in the SD-WAN market. So what Cisco did, they purchased company Viptela. They started supporting development support for the V-Edges hardware because they overtook that company. Then slowly and gradually, what Cisco did, they started developing the new iOS XE images on which SD-WAN is supported. So basically, they started integrating Viptela components onto the iOS XE images. And now V-Edges are being phased out. I have seen organizations who are running, let's say, 2000 V-Edges, right? V-Edges are now phased out. Cisco has stopped the supporting selling V-Edge as hardware. So now Cisco wants only to retain SD-WAN on their Cisco routers. So it was, you can say, business strategy.
Okay, got it. So, and 8000 Catalyst is more familiar, correct? Compared to Cisco 1K ASR.
It depends because why Cisco retained iOS this SD-WAN on 1000, 4000 so that customers can reuse their hardware. So who want to reuse their existing hardware, they don't want to purchase new routers, they still use 1000 and 4000 routers or ASR routers. If somebody who is new to Cisco SD-WAN, new to Cisco environment, then they prefer buying these devices.
So why it is the Catalyst?
All these devices, they have two modes. You can use them in SD-WAN mode.
Yes.
Or use it in a normal
yes.
router.
All these Cisco devices, we can either run them as plain router or SD-WAN device. Both are mutually exclusive. If a router is running in traditional environment, plain router, it cannot accept the SD-WAN commands. If it is running in SD-WAN environment, it cannot accept the plain router commands. So both are mutually exclusive. Yes, anyone? Any more questions?
So can you also share the list of content in the SD-WAN, what you are covering?
We will. Yeah, we will be talking about those things tomorrow, right? I'll share the content, and for now.
And what is the duration of the course and cost?
Yeah.
When it will
So duration would be around 25 hours, right? And if you see my screen,
yeah,
this is the certification and the contents that we would be covering.